Hello everyone and welcome to the first video on HATS-WA. HATS-WA is a tutoring service and I am the owner, Malcolm Hanson. Welcome. Today we're going to be looking at algebra. So algebra is a topic that a lot of students have difficulty with, and it introduces new concepts that can scare or confuse students. This is something that I really enjoy and I really enjoy teaching, so I hope that this is a really useful video for you. The main focus of this video is going to be on factorizing quadratic trinomials. Now I apologize if that sounds like a big word to start with, but we're going to start from the real basics and move towards there. The only previous knowledge that I expect you to have for this video is just addition, subtraction, multiplication, division, and knowledge of your times tables. So first of all, what is a variable? A variable is something that can change. A variable is an unknown quantity. So if you think of it as a container, something that we don't know the quantity currently, but that we can work out. So variables will change between questions, but they will remain the same within a particular question. So for this particular question, let's look at, we have 3 pencil cases. So this is our containers. And the amount of pencils in them are equal in each one, and they add up to 15 in total. So 3 pencil cases add up to 15. We can represent this as 3C, where C is the amount of pencils in a particular pencil case, equals 15. So we just choose a letter that we want to represent that unknown quantity. In this case I chose C for pencil case. And then we can solve the problem. So we'd say, well, if 3 lots of it is 15, then 1 lot of it would have to be 5. So essentially what we've done is we've divided each side of the equation by 3. So we divide by 3 to get 1c, which is essentially just c. That's the way we write it in algebra. If you just got one of them, it's just that letter. And then 15 divided by 3 is 5. So as long as you do the same thing to both sides of the equation, that's how you can solve algebraic equations. Second of all, it is important to understand the lettering. So for instance, let's say we have 5 apples. We can write that as A for apple, and we have 5 lots of those. 1, 2, 3, 4, 5. We can represent that as 5 lots of apples, or 5 apples, 5A. That's the way that we can represent letters a little bit easier in mathematics, and just saves us a bit of time. Instead of writing A plus A plus A plus A plus A, we just write it as 5A. We collect those like terms. So we do it similarly here. If we have similar terms, we can group those together. So let's say we have a spearmint and bubblegum. So you've got 2 spearmints plus 4 bubblegum plus 6 spearmints plus 1 bubblegum plus 2 bubblegum. Now we want to collect those. So we want to collect the spearmints, we want to collect the bubblegum. So collect the S's, collect the B's. I'm going to start turning over to just letter language rather than saying a particular example each time. So 2s plus 6s, we'll end up with 8 lots of s. 4b plus b plus 2b, we end up with 5, 6, 7b. So 8s plus 7b, we're just combining those like terms. So collecting like terms is what it's called. So what we're going to do now is we're going to look at if we have 3 lots of 2d. So we have 3 lots of 2d. We can represent that as just 3 multiplied by 2d. We don't actually need a multiplication symbol in algebra. So when you just have 2 numbers next to each other, usually separated by a bracket or something like that, if they don't have any symbol between them, we imply that they're multiplied, and that just makes our life easier rather than having to write lots of multiplication symbols, which can get confused with the x symbol that we use in mathematics. So 3 lots of 2d, well, we'd have 2d plus 2d, 2d plus 2d plus 2d, and we end up with 6d. Great, so now that we understand terms, we understand what the variables are, we're going to look at expanding variables. Again, I might go into some of the language of this a lot more in another video, but the main thing I'm focusing on here is getting to expanding and factorizing. So let's have a look at some expanding examples. So let's say we have 6 lots of 23. This is a problem that you might have done yourself, so you might say, well, how would you solve that if you got that problem? You don't know your 23 times table, but you might split it up. You might say, well, we've got 6 lots of 20, and then we've got 3 lots of 20, and then we can add those together. So that's a pretty common way of dealing with that question. 6 lots of 20 plus 3 lots of 20. 6 lots of 20 plus 3 lots of 6. So we would have 6 times 20 would be 120. And then 3 lots of 6 would give us 18. We'd add those together and we would get 138. And that is a common way that we are solving that problem. So what we're doing is we're saying 6 lots of 20 plus 6 lots of 3. So the way that we can actually rewrite that is we can say 6 times 20 plus 3. And what we need to do is we need to go and take the 6 and multiply it by both the 20, which we've done down here, and then multiply it by the 3, which we've done down here. And that's going to give us our solution. So let's have a look at a bit more algebraic example of this. So this is where we're factorising. We're factorising the 23 into 20 plus 3. Very basic example of it, but we will be doing some more difficult ones soon. So let's have a look at a second example. If we have 5 times 3a plus 2b. Now, if we're going to solve this one, we need to go 5 multiplied by the 3a, and then 5 multiplied by the 2b. So again, make sure you multiply it by both of them and use the symbol in front. So 5 multiplied by 3a, 5 multiplied by the plus 2b. Make sure you include the symbol when you're multiplying the one before the next number. So if it's a negative, make sure you're doing it as a negative. Okay, so 5 times 3a would give us 15a. 5 times 2b would give us 10b. And so that is our final solution. That's all we can do, because a's and b's, we can't combine apples and bananas or whatever you have those two symbols as. They're different symbols. Great. So this is the distributive law. So whenever you have this system, wherever you have a multiplied by a b plus c, so in this case we would have 5 is our a, it's in the same position in front of the brackets, our b would be our 3a, and our c would be our 2b. Don't worry too much about that explanation, but the main thing I want you to understand is the fact that we're multiplying the a by the b, and then we're multiplying the a by the c. Regardless of what the a, b, and c are, that's our process. So this is known as the distributive law. And basically you're distributing that a across the b and the c. That's the way you can think of that. So that's really important to understand. Distributive law is important in algebra. Next, factorising. So let's say we have something like 4 plus 28 plus 20. We can then factorise that. We can say, well, what number goes into all of those? Well, I mean, we could take 2 out of there. 2 goes into 4, 2 goes into 28, 2 goes into 20. But we could actually take a whole 4 out of there. So we could say 4 times what gives us 4 would be 4 times 1. 4 times what gives us 28. 4 times 7. 4 times what gives us 20. So 20 divided by 4 gives us 5. So 4 times 1 gives us 4. 4 times 7 is 28. 4 times 5 is 20. And so we could solve this problem as just saying, well, that's 4 times 8 plus 5 is 13. So let's say 4 times 12 is 48. So 4 times 13 would be 52. And you can then go and check that as well. So we can go and say, well, let's say 4 plus 28 is 32, plus 20 is 52. So yes, it would give us the same solution, whether we factorised that or whether we did it the initial way. Factorising can make things a lot easier when you have more complex problems. So this one might have been easier to do just adding, but as you get to more complex problems and as you get to use algebra, it can become a lot more tricky, and so factorising becomes necessary. So let's say we have 3a plus 6b plus 15c. We want to factorize this. So what number goes into all three of those? So 3 would go into all three of those, so we could take 3 out of that. So 3 multiplied by a would give us 3a, 3 multiplied by 2b would give us 6b, and 3 multiplied by 5c would give us 15c. So if you multiply it through, so let me just go and multiply it through as a check. 3 multiplied by a is 3a, 3 multiplied by 2b is 6b, 3 multiplied by 5c is 15c. So it's the exact opposite process of what we're doing. Expanding, we're going and putting a number through the brackets, and we're making it just a standard series of numbers. Factorizing, you bring it inside the brackets again, so you're taking it from that series of numbers into the brackets. Let's do one more just to check the concept and check we understand squared terms as well. So let's have a look at if we have, I need to grab this symbol here. So we have, let me just write something there, grab the symbol, and so we have 20a squared. So I'm just going to change that s to an a. Plus 10a plus 15. So we wanted to go and factorize that, so let's see what number goes into all three of those. Well, 2 would go into the 20 and the 10, but not the 15. 3 would go into the 15, but not the 20 and the 10, so you need a number that goes into all three of those, which would be 5. 5, and then we would need 4a squared in the brackets. 4a squared. And then we would need to add 4a. So 2a. 5 times 2a would give us 10a, and then 5 times 3 would give us our 15. So that would be factorizing that particular equation. We can't combine squared terms and normal terms. So the a squared and the a are different. If we have a multiplied by itself, it becomes a new thing, whereas if we just have a, those can combine with other a's. So don't ever combine the squared terms with the normal terms when you're factorizing. Now, what we're going to be doing is we've actually been bringing things like this, which is a quadratic trinomial. We've been taking that into brackets, so we've been factorizing it. We're now going to be expanding some in order to get quadratic trinomials. So this is a really basic factorization. We'll be doing some more hard factorization of quadratic trinomials soon, but we're going to be expanding some for now. So expanding these, we would have something like, let's say 14 times 36. This is a really basic, just numeric example. 14 times 36. Very hard to do in your head, but you can simplify it. So we could say that's the same as 10 plus 4 times 30 plus 6. We split it into the 10s and the 1s. That's often what you do when you go and do your sort of short multiplication, like you do your short division, that sort of thing. When you use those techniques, you're basically doing that. So you're splitting into the 10s and the 1s, and you're multiplying it through. So now what we can do is we can go and multiply these through, but there's a particular method that you need to understand to multiply it through, and it's called FOIL. Basically, we're multiplying each thing by each other thing. So FOIL, first, outside, inside, last, I'm going to be showing you here. So first number of each bracket, multiply it by the other one. Outside number of each bracket, multiply them together. Inside of each bracket, and then the last of each bracket. So we're going to go and do that here. So first we've got 10 multiplied by 30. So 10 multiplied by 30 is 300. Outside we've got 10 multiplied by 6, which gives us 60. Inside is 4 multiplied by 30, which gives us 120. And then last is the 4 multiplied by the 6, which is 24. We can then go and combine those, so we have 360 plus 144. All I've done there is I have combined the 300 and the 60 into 360, and then I've done the 120 plus 24 into the 144. Just an easy simplification method. And then finally here we would end up with 504. 360 plus 144, 504. You can go and check that on a calculator to make sure that that's correct, but this shows you that the method works, so the FOIL method works. Now we're going to be using it with some algebra. So 2a plus 5 multiplied by 4a plus 8. So again, same method. Make sure that you understand the method. I'm going to draw it again for this one. We won't do it for the next one, but we'll do it for this one. So first of each bracket, so I'll put an F there for first. Outside of each bracket, so I'm going to put an O there for outside. Inside of each bracket, I'm going to put an I there for inside. And last of each bracket, I'm going to put an L there for last. So let's go and actually solve that now. So 2a multiplied by 4a, let me grab the squared term again. So we've got a times a is going to be a squared, but we'll have 2 times 4 is 8, so it's going to be 8a squared. Sorry, we're having a bit of technical difficulties, there we go. 8a squared. Plus, so we've got the outside, so 2a times 8 would give us 16a. The inside would be 5 times 4a would give us 20a. And the last would be 5 times 8, which gives us 40. Combine all those, so we can't combine the a squareds with the a, but we can combine the a's together, so these a's. And if we do combine that, we will end up with 8a squared. Let me just grab that a squared term. Plus 36a plus 40. So again, it's really important that you have working out set out similarly to what I do. So I have each step just having a little change done to it. So for instance, let's look back at here. You've got 300 plus 60 was changed to 360. Just below it, 120 plus 24 was changed to 144. Here we have 16a plus 20a was changed to 36a. So it's just one or two small changes between each line of working, and that just makes the working a lot easier to follow. Especially if you're doing tests, it's really important that your working is easy to follow so that the teacher can give you follow-through marks, for instance, and see what you've done correctly and what you've struggled with, for instance. Okay, let's move on to a last one. So let's say we have 3s plus 4 multiplied by s plus 2. So again, follow that same process. The first one of each bracket will give us our 3s squared. So let me just grab that s squared term. 3s squared. Then we have the outside of each one would be 3s times 2, which would be 6s. The inside of each would be 4 times s, which would be 4s. And then the 4 times 2 would give us 8. So we end up with 3s squared plus the 6 and the 4, so 10s plus 8. So we've collected those s terms. Now all of these that we've come up with, the 8s squared plus 36a plus 40, and 3s squared plus 10s plus 8, that's known as a quadratic trinomial. You've got three different terms combined to make up our quadratic. Quadratic just means you've got a squared term in it. So linear equations, you just have like mx plus c. Quadratic, you've got ax squared plus bx plus c. That's more of a graphing concept. I won't go into this that much this video. So let's have a look at factorising quadratics. So you can actually take something that looks like this and put it back into a form that looks like that. And that can make it a lot easier to solve problems with these. We'll go into that in another video as well. But basics of factorising quadratics. So let's say we have x squared plus 4x take 12. Actually, let's do another one first. Let's do x squared plus 7x plus 10. So x squared. So the a in this case is just 1. We're just going to x squared. The b in this case is 7, and the c is just 10. X squared plus 7x plus 10. We need that to be in this form. So we need that to be in the form that we started with up here. So we need it to be x plus a, x plus b. I've got a nice little table here that can help you do it. This is something that I often use with my students, and they find it really, really helpful. So when you're doing these problems, the way to solve them is we need to have two numbers that add to give the 7, or to give the middle term, the b, and two numbers that multiply to give you the last term, or the 10, or the c. So you'll notice that this technique will be used throughout all of these problems that we're doing here. So if I just go and fill in this table, factors of 10. So we're doing factors of whatever the multiplication term is. So it's easier to find the factors of the multiplication term and then work out how those two can add or subtract to give us the middle term. So if we've got 10, we can have 1 times 10 would give us 10. So factors of 10. We could have 2 times 5 would give us 10. And those are really the only two factors, or the four factors, sorry, that we can use for this problem. So 1 and 10, if we were to be trying to get to 7, so we're aiming for this add number, we could have 10 minus 1 would give us 9, or 10 plus 1 would give us 11. The closest to 7 is 9 out of that. We could have 2 plus 5 would give us 7, which is exactly what we're looking for. And we could have, let's say 5 minus 2 would give us 3. So what we're looking for is 7. So we found that. So let me highlight that one. And then what we're doing is we're saying we need to add 2 and add 5 to give us the 7. So this A would be 2 and this B would be 5. And we can go and check that. With algebra, it's really useful because you can go and check your solutions to a lot of problems. So this is just us checking it. So let's say we have x plus 2, x plus 5. And then we were multiplying that through, so we'd get x squared plus 2x plus 5x plus 10. And we combine those terms, and we end up with x squared plus 7x plus 10, which is exactly what we started with, so yes, that is correct. Okay, let's have a look at our next question. So, this is going to be different. Again, x plus a, x plus b, we need it in that form. We're going to start off with x squared plus 4x, take 12. So let's get our table again. If you can see the numbers straight away, that's great. You can use those. But if you struggle, this is a really useful technique. So again, as a reminder, what are we doing? Well, we need to have them multiply to give the last term and add to give the middle term. So we need them to add to give the 4, and we need them to multiply to give the negative 12. Don't worry about the positives and negatives too much yet. We'll sort that out once we've worked out the numbers. So let's say factors of 12. Looking at factors of 12, we would have 2 and 6, 2 times 6, or 1 times 12. Or we could have 3 times 4. So those are 6 factors of 12. If we're trying to get to 4, well, 1 and 12 isn't going to get us very close. It would get us to 11, or let's say negative 11. 2 and 6, we could get to negative 4 or negative 8. Sorry, negative 4. And negative 4, sorry, no, we could have positive 4. We need a positive number for the middle one, sorry. And then 3 and 4, we'd get to, say, 7 or 1. So the closest we would get is, let's say, 1. So 2 and 6 will get us to 4. We need to add 6 and subtract 2 to get us to 4. So let's go and check our solution for that. So we've said we need to add 6 and subtract 2. So we end up with x squared plus 6 take 2, plus 6x take 2x take 12. And so we end up with x squared take 4x, plus 4x take 12. Yep, that's exactly what we're looking for. So yes, that is correct. So our A would be 6 and our B would be -2, x take 2. So you can see we're going from this form back into these other forms, and all we have to do is just follow that table. A lot of students really struggle with this if they don't have the table, so this is a method that I've thought would be really useful. Okay, let's do another example. So let's, again, x plus a, x plus b, and we want to solve this one now. So we want to have x squared take 5x take 24. So factors of 24 in this case, remember we're looking for the last number. If we have factors of 24, we could have 1 and 24, or 2 times 12, or 3 times 8, or 6 times 4. We need these to add up to -5. So if we had, let's say, -24 plus 1, we'd get -23. That's the closest we would get to -5. We could have -12 plus 2 would be -10, or -12 take 2 would be -14. So -10 is the closest we can get to -5. And then -8 plus 3 would give us -5, so that's going to give us exactly what we want. And then 4 and 6, again, we don't really need to consider this anymore because it's not going to give us what we want, but let's have a look at it, and we would get closest is -2, for instance, or -10. So -2 would be closest. So we found what we need. We would need to subtract 8, we need it to be negative, and add 3 to get -5. So subtract 8 and add 3. So let's go and do our check. So we have x take 8, x plus 3. So that ends up with x squared plus 3x take 8x take 24. Simplify that, we have -8 plus 3, and we get -5. So x squared take 5x take 24. So yes, that gives us what we started with, and that is correct. Okay, one last one. So in this case, we are going to have I just write this x plus a, x plus b every time so you can see what form we need to have it in. And the question is x squared plus x plus minus 56. So x squared, whoops, plus x minus 56. So again, if you can see the numbers straight away, then feel free to go for that. But let's go and do the table again. So this time we need factors of 56. So you could have 1 and 56. We could have 2. What times 2 gives us 56? So it would be 28. We could have 3 with any 3's going to it. Not that I can think of right now. 4's, 4, 10, 11, 12, 13, 14. Yeah, so you could have 4 times 14. That might not be one you actually think of straight away. It's getting a little bit outside of comfort zone, but that is one. And then we could also have 7 and 8 would be the most common that we'd be looking at. So 1 and 56, we're not going to get anywhere near 1. 2 and 28, we're not going to get anywhere near 1. 4 and 14, we'd get to 10. 7 and 8, we'd get to 1. So that's the one we're looking for. So we could get to 1 with 7 and 8. And so how are we going to get there? Well, we need to add 8 and subtract 7 to get to 1. So we need to add 8 and subtract 7. And that should get us to 1. Now let's check that that's correct. So we have x plus 8. X takes 7, and we want to check that that gets to x squared plus x minus 56. So x squared take 7x plus 8x take 56. Combine that, so if plus 8 minus 7 would give us plus 1. So this is really useful to check that you've got the right order, so you might end up with -1 if you did the signs wrong. So make sure you do check. X squared plus x take 56, which is exactly what we started with. So yes, that is what we were looking for. So for any students that are going through this at the moment that are needing to factorize quadratic trinomials, I really hope this is useful. For anyone who just needed an intro to algebra, I hope this was really useful just for the start of the video. For future videos, I'll be aiming to look at going through some more algebra topics potentially, some other calculus type stuff. I'll go through a lot of different topics, but this will be sort of my topic focused playlist. I will also have a requests playlist where students or other people may present some problems. I'll do a couple of problems every so often, and I'll put those up on the requests page. Thank you all for watching. I hope this was really useful. And remember, HATS WA, we're aiming to build self-confidence, skill, and success. See you in the next video.